As he said, this presentation is a bit more technical. I made it quite accessible, so I think anyone should be able to follow it if they were a bit aware of how Bitcoin works. PARTICL. This is actually my first presentation ever. I haven't really done any public speaking or anything, so I guess an introduction is good. Yeah, as I said, I've been anonymous up until now. I haven't really revealed my identity or anything like that. I'm currently doing my bachelor's degree in business engineering. I'm in my last year. And I'm 21 years old, which I guess is quite young compared to you guys. I don't want to call you old, but I started with computers roughly at the age of 12. I was playing this game, and there was this cheating engine that you could use, and you could write your own custom cheats in it. And that's kind of how I got into Java and security and automation, basically, because it was a very tedious game. You had to spend like a lot of hours on it. And I'm mainly interested in this stuff. I'm not really going to go through the list. I'm also not a native English speaker. I do speak Dutch and a bit of French. So in case you have any questions and you're more comfortable in those languages, feel free. Currently, I do research and development for the PARTICL project. I'm also a maintainer of privacytools.io. If you're not aware of what it is, it's a website where you can get the basics of how privacy, in general, just all these kind of tools that you can use, from beginners to a bit more experts, I guess. So first, I want to talk a bit about open source and funding, because they're a bit difficult. So there are many open source projects that are really struggling to get by. I mean, these are obviously the ones that are doing quite well. But they're mostly supported by grants and user donations. Like Tor and Signal, they rely on funding by the US government. And so, as you are aware of, the traditional model for open source software for the traditional business model doesn't apply for open source software. And I think that's kind of where cryptocurrencies step in and provide an interesting alternative to explore. But I do want to spend some more time on this, so I'm going to talk about two projects in particular that are related to privacy that we've seen struggling with issues. And one of them is GNU-PG. I guess everyone is aware of what it is. And it was actually on the verge of abandonment. It's maintained by Werner Koch, a German engineer. And he was inspired by Richard Stallman, actually. And they raised a substantial amount of money after a cry for help when an article was released. And GNU-PG is actually quite fundamental to the core of everything that this movement started. And Copperhead OS is one of my personal favorites. I'm not sure if anyone is aware of what it is. Raise your hand if you know what it is. Okay, cool. Some people are aware of it. It's basically a hardened Android operating system, and they upstream quite a bit of their work into the official Android operating system. And it's developed by Daniel Mickey, also under the username Stircat. And the business side of things is handled by James Donaldson. And like many projects, they kind of have to find their way. And it was open source, but now it's not free anymore. They have adopted a more restrictive license that basically allows you to look at the code, check it out, but you can't sell any device with their operating system, which is kind of sad, as it would help getting people better phones for a cheaper price. But they have to sustain development, and developing an operating system just isn't easy. And there are only a few people in the world that can really do this properly. So there's this one category that actually does quite well, and that's cryptocurrencies. And there's a bit of an economic incentive for developers and community to get together and really make this project a big deal. And they're not relying on charity or grants. I mean, some do, and sometimes it has to, but it's interesting how they get around to funding themselves and their projects. And so definitely some privacy currencies that are doing very well. So this model really it works for financial privacy, and hopefully we'll see more privacy projects sustained by this model. I mean, these cryptocurrencies, they're not just focused on financial privacy, they're more than that. They build an ecosystem, and we've seen it with Zcash building the Orc network and Monero with the I2P router. It kind of spreads into a more broad sense. then typically we attach to these currencies. So I want to present to you about PARTICL and give you an intro on how we do this thing. And it's a platform that, in some sense, it integrates a variety of tools to take back your privacy. And we're a cryptocurrency. We provide some private transaction types. We have SMSG, which is an end-to-end encrypted messaging solution. And we're working on the private marketplace at the moment. I'm going to grab my bottle of water, by the way. So why would you want to build a private marketplace, actually? You know, marketplaces these days, like Amazon and eBay, they actually require an absurd amount of trust and personal information too. For Amazon, for example, you know, you have to give them your credit card information, and you know, if someone hacks them, you know, you're basically fucked. And centralized marketplaces, they also have a lot of power over buyers and sellers. Amazon, they have these really complex algorithms that actually, you know, can steer people to certain products or certain brands. And sellers, they also are reduced in what they can do. And I found that businesses are generally more interested in privacy than, you know, the average person, because they have a bit more to hide, I guess. And in an open system, you know, competitors can just come in, identify your customers, your best-selling products, and more easily, you know, identify your strategy. And that's kind of where we step in. And I'm going to give you a bit of an overview of our system. Because, you know, it's a bit technical, I try to make it as broad as possible and not go into depth too much. But, you know, what we've currently done, you know, is we've built a private cryptocurrency on confidential transactions. Secure messaging is an alpha version. It's a decentralized network for messaging and storing the market listings. It's, you know, it's a bit message variant, so in case you're aware of what that is. Currently, we're in progress of building the open market protocol. We have Ring CT on the test network, and we're working on the marketplace MVP. Yeah, I'm a bit sick, so we might. The goals of a private marketplace can be summed up like this. We want to minimize the information leakage to other nodes. So, you know, when you're searching for an item or viewing a listing, you don't want to reveal to a particular node that you're interested in that. And we also want to anonymize the communications between buyers and sellers. So a message should not reveal the sender. It should not reveal the receiver's public keys or their IP addresses. And another thing that we try to achieve is linkability of transactions, more particular in purchases, and their respective market listings. So if you're buying a coffee machine and we see this transaction network, we don't want you to be able to identify that this might be a purchase for a coffee machine. And one of the other things we try to do is obfuscate the exact origins of a transaction, both from passive observers and active participants. So the presentation will follow about the same workflow as a complete buyer and seller interaction. So basically from publishing the listing down the way to the buyer actually paying for the item. So, you know, first the typical Bitcoin transaction, you have this pub key script, right? And it's basically, if you're not aware what it is, it's basically a certain kind of code that locks the transaction. And only if you give it a valid signature or whatever unlocks it, you can spend the output. And we actually make a special pub key script for the output, which is the next slide, and it allows us to request a fee for registering the market listing. And this is a bit of a packed slide, but that's basically how it's done. I use the op return statement because we want it to be compatible with all these kinds of different Bitcoin-based blockchains. The op return in Bitcoin has a bit of a, how do I say it, a limitation of 80 bytes, so you have to be a bit careful with which data you include into it. So basically, this allows us to create an index in the blockchain of the marketplaces. So we're not actually storing the data of the market listing in the blockchain. It merely stores references to where it can actually grab that data and do what it wants. So we have this virtual opcode. So it doesn't really exist because it's after an op return and that output is unspendable. But it indicates that a market listing should be added to the listings. So we also have the item public key, which is basically the index of the signing public key. And that's used to aggregate multiple listings to a single public key. So, you might have like a coffee machine, but you might make like 3 different listings for it because it has like 3 different colors, for example. And we want to have like, in the future, if you have like a reputation system, we want to be able to have a single reputation for multiple items. And so yeah, the protocol ID basically specifies where it should get the data, like which protocol or network it should get it from. So we have blockchain only stores references. And the listing hash, it's just to check the authenticity of the data that's returned. Some protocols do this by default. They use the listing hash to actually also be the identifier for the data. So if they want to get the data, you just say, hey, give me this hash. By this hash, give me the data. And so a listing ID in some cases is a bit necessary in case you want to have like URLs, HTTP protocol or HTTPS. You have to have this unique identifier. But it can be too long for some blockchains, obviously, because of the op return being a limitation of 80 bytes. So we just call this structure data storage reference, data storage network reference. It's a bit of an abstraction layer, basically, when we want to allow for different protocols and networks in the future and expand it instead of sticking to what we have. So currently we have like a few protocol IDs, so basically the URL, HTTP, HTTPS, and we have SMSG, which is what we're making. But in the future, we'll also be looking at IPFS and ZeroNet and see what they have to offer in terms of privacy. So I'm going to give a small introduction of SMSG. Is anyone aware of like how BitMessage works here? Okay, I'll go into it a little bit deeper. Basically, you have this whole network of nodes. And if you want to send a message, like Alice, she's trying to send this message to Bob, what she does is she just announces to all her peers, like, hey, I have this encrypted message. And what they do is they just all store a reference of that message. They actually store the content of the message. And it propagates all through the network up all to Bob. And it's basically a variant of BitMessage, but BitMessage uses Python and OpenSSL. Ours operates over the same networking stack as the PARTICL core, which is our blockchain. And it's in C++ and uses libsecp. And it only stores this for about 84 hours, although in the future we can make that variable depending on the message. So some benefits of local storage is basically that there's no information leakage. There are other protocols, other network types like DHT lookups, DHTs, and a DHT lookup reveals a lot of information of what we're trying to access. So another node on the network knows that you're looking for a particular type of content. And there are some improved DHT lookups in academic literature, but there aren't really many implementations out there. And with SMSG, nobody knows what you're searching or accessing. And another benefit is a very low latency in the user interface because images and stuff, they are already on the disk, so we can quickly grab them in. And some drawbacks of local storage, obviously, is that it doesn't scale. Millions of listings are going to take up a few terabytes at least. And so it doesn't scale. But if we look at a typical listing, images tend to be like the most. If you take an average of 4 images per listing, you end up with a big bunch, like a megabyte of data. And in the future, we can actually move this to solutions like IPFS and still have that text data on SMSG, which still allows us to do searches and get an idea of what the content is without having to store the images. And some future improvements that we want to do to SMSG is more anonymous broadcasting. I'm not sure if any of you are aware of Dandelion, but basically it was invented for Bitcoin a few months ago, a few years even. And what it allows you to do is a more private way of announcing, I want to have this, I want to spread this particular content over a network. And what it happens is 2 phases. First, it only sends it to one node. In typical systems, it actually sends it to all the nodes at once or with a random time interval. But now it just travels down a path, and then the typical spreading phase happens. And blockchain analysis firms, they actually, what they do is they add these nodes that are malicious, and they just check at what time they receive the message, and then they can somewhat pinpoint down to who sent the message. And that's what it's trying to solve on a Bitcoin network. But we can equally apply it on SMSG because it's also just spreading a particular content on a network. Currently, we're just using flooding, so I advise you to use it with Tor if you want to experiment. One other thing is that we do not support perfect forward secrecy, which is a particular trait that's quite standardized among, people really want it in a typical end-to-end encrypted message solution. Basically, it's a standard right now. So we got this message. Let's go to how do we decode it? We've registered it on the blockchain. So we're trying to make we're making an open market protocol, and it's an open protocol for marketplaces. So basically, we want to standardize the interactions between buyers and sellers into a single format. And it's actually two formats. We have the public listing content, public listing format, which basically contains all the data about the item or service, like description, images, and all that kind of stuff. And then the private message format, which is currently a work in progress, though, it just deals with the communications between buyers and sellers. So if the buyer has to give up his address, that goes into the private message format. It contains actually all the sensitive information. Also contains the transaction in case of escrow and stuff. You can already have a look at the Git book. So now, why would you want to make an open market protocol? For the moment, there are not really any other specifications out there. Everybody just does their thing. They don't really bother to specifying it. But eBay and Amazon, they have their format, but they're all separate. They're not the same. And we want to give back the power to the sellers in that aspect. We want to give portability of item data. If you're currently selling 1,000 items on Amazon, and suddenly you decide okay, eBay is alive again, let's sell some items there, then you'll have a hard time moving that data from Amazon to eBay because these different formats. And there are third-party services that allow you to do that, but you have to pay a service fee and all these kinds of problems that you don't have with an open format. And this format is also designed to work in a decentralized network, and specifically also designed for cryptocurrencies. So worth noting, the protocol actually works for any type of cryptocurrency. It's not only working for PARTICL. If you want to build a marketplace using this protocol, go ahead. It can equally be working on Bitcoin or whatever. So the private message format, so the buyer found an item he wants to purchase. So he contacts the seller using this format. As I said, it should be encrypted because it contains sensitive information like the address of the buyer and raw transactions. And yeah, just to explain, raw transactions are actually used because it allows us some robustness in terms of if you want to implement Ethereum or something on it, they might have a completely different structure, so we just send them over as raw transactions and you have to decode it. But don't forget your sanity checks because the seller can send you anything back, and if you just sign it blindly, you don't know what's in it. So this is about the general workflow of a private message format. So the buyer, he does a bid, and then he creates an MPA lock, which is basically his buyer inputs and his outputs. And the seller has the option to accept it or either reject it. And if he accepts, he does the MPA lock, he returns the MPA lock object, but he adds his inputs, and it's a multi-signature output. It's signed by the seller at this stage, but it still has to be signed by the buyer. And the seller can also automatically send the release transaction. And he can automatically build the release transaction of that multi-signature output because he has no incentive to. He wants his money basically. MPA is basically marketplace action. Yeah, sorry, I should have explained that. And basically because of SegWit, PARTICL having SegWit, we don't have transaction malleability, so we can automatically already do this stage. This one doesn't have to be broadcast yet before we can do this one. So I'm going to go a bit more into private transactions now and why they're necessary. So I want to have a small word about confidential transactions and the background of it. So if you're not aware of what confidential transactions does, it's basically it blinds the amount being transferred from a passive observer. So if you see this transaction on a network, you don't know how many coins were transferred basically. It was invented by Gregory Maxwell is built on libsecp with some additional modules of the Elements project. The Elements project did an integration of CT on Bitcoin Core first. And we've implemented it, well, Technovert implemented it on Bitcoin Core 0.15. And what this does, it allows for hidden amounts in multi-signature outputs. And that's actually quite critical in some sense, because it's required to prevent amount linkability, which is a flaw in marketplaces using Bitcoin. So as I said before, we want to disconnect the market listings and the transactions, especially from passive observers, like blockchain analysis firms. And we want to have unlinkability between transactions, the actual purchase, and the item or service itself. And it's a bit of a fatal flaw in marketplaces using Bitcoin or any network with public amounts. And especially, Bitcoin is quite a large network, but PARTICL is, at least at the start, it's going to be a very small network. So amount linkability is a real issue. And so if you're selling a coffee machine for this very particular amount of Bitcoin, and someone sees a transaction on our network with this amount, and they also see a listing active for this specific amount, they can see, oh, these two correlate. And so the amount is actually basically potentially a unique identifier. And you don't want these blockchain analysis firms to know exactly what transaction was for. That just gives them a whole new layer of information to categorize your transaction. And this is typical Bitcoin transaction displayed there. So with confidential transactions, because it blinds the amount being transferred, that improves also the unlinkability between transactions, purchases, and the actual item or service. So I'm going to go a bit fast through the private transaction part because you can go deep very fast. And so it obfuscates the origin and receiver of a transaction and also hides the amount being transferred from a passive observer. And it's invented by Shen Noder. He's a Monero developer. But it also builds up on a lot of inventions of Bitcoin Core developers, actually, like stealth addresses, which was in 2014 by Peter Todd. Adam Back improved the original ring signature scheme and made it efficient LSEGs. And then later on came confidential transactions by Gregory Maxwell, which fits in with some minor changes. And Technovert ported ring CT to the Bitcoin Core 0.15 code base. Because we already had a lot of, we already had this confidential transactions infrastructure. We only had to do the LSEGs and the stealth addresses. And this is basically kind of the overview of how it goes, the inputs, MLSEGs, and CT. It's currently active on the test network. And the next few slides are like a very basic introduction. And yeah, I'm just going to go to them. So if you want to understand ring CT, because it actually exists out of multiple technologies, and I think stealth addresses are by far the easiest to understand. Both, yeah. And I'm going to just start with this one because it's the easiest. And so Alice and Bob, they're trying to do a transaction, but they don't know how to do it without stealth addresses privately. So Bob, he has a public stealth address, and Alice knows that. And what Alice can do is create a hidden address built on the stealth address of Bob. And Eve, the malicious observer, she cannot link the hidden address with the stealth address. And Bob, when he receives a transaction, he can actually recreate the hidden address. And that's because it has metadata in the transaction. And obviously, only Bob can spend the coins. So now that we have stealth addresses covered, we can go to ring signatures, more in particular, unique ring signatures. And they're basically a special type of input that does not reveal the real spender. So we have the real spender, Alice, here. And we also have a bunch of mix-in inputs. And from a passive observer standpoint, you can't actually know which one of these three actually executed the transaction. And obviously, we have to have double spend prevention, and that's done by key images. So Alice, her input actually generates a key image that is unique to her input, and every input must only generate one valid input, one valid key image. And what we do is record all these key images, and we reject just the duplicates because we know it's been already spent. I think that's the end of the presentation, actually. Thank you. Yeah.
Thank you very much. Great presentation.
Thank you.
So we have a lot of time for questions. So any questions?
Yeah, hi. I actually have two questions. The first one would be, was there a specific need to invent a new coin, or why couldn't you just use Monero? Was it the lack of multisig? This is the first question, and the second question is, where is the data like images and text stored at the moment? I didn't get that.
Okay. So basically, as I said, Monero at the moment doesn't actually have multi-signature. So you're basically, you can't do anything without escrow. I heard that they were actually working on it, and that would actually be very interesting. But currently, also Monero doesn't actually have this scripting system that Bitcoin does, and we can do some quite cool things with the scripting system, actually, like time lock transactions and stuff like that. And that's, unless Monero changes their architecture, you can't do that kind of stuff, at least as long as I know. And your second question, yeah, currently it's stored on SMSG, especially for the MVP. We're storing everything on SMSG. And we actually looked at existing marketplaces and checked like how many data it's using, and then we try to estimate it. And we think there might be a lot of users, but it's the sellers generating all the data. So you might have like a ton of users, but if there are only a few sellers, they won't really generate a lot of the data on the listing. So we can currently do it on SMSG.
Next question, please. Yeah.
Hi. First of all, impressive focus on anonymity. I really like it. I also have two questions. The first one is, there are attempts to implement Bitmessage in C, and I think that there's one in C#. Have you looked at those, and if maybe that's something you might reconsider in the future? And the second one is, as far as I know, the libsecp 256K1 only supports signing and verification and doesn't support encryption and decryption. So I think I'm missing something here.
Last time I checked, actually, they have a implementation of ASR, the CBC mode. I mean, at least when I last checked in the code. So it does support encryption, CBC, and they also have a HMAC module. So those two things are in libsecp, I believe. And your first question, I kind of forgot. Could you give me a hint? Oh yeah, Bitmessage C. So I've actually been a bit active on the Python implementation of Bitmessage. When I talked about Dandelion, I made an issue on their implementation of Python, and I told them, hey, there's this Dandelion thing, and they said, okay. That's actually cool, and they actually already had a bit field specified for it. Yeah. Yeah, and oh, that's you. Nice to meet you, actually. And yeah, they're starting on. Well, he looks a lot different than on his picture. And they really jumped to it. I think you're talking with Andrew Miller, and that's really cool, actually. I think Dandelion is definitely one of those things that you should implement. And I was also the guy that said like about SHA-1, that you guys already were working on that.
Okay, great.
I mean, also really a round of applause to the guys doing Bitmessage. Really, they're amazing.
Yeah.
Hi, I want to ask what will be the structure of if I'm a seller and I want to send some items, will I have a kind of a shop where all my items are listed together, or will the items be only by category? And also, will I be able to link to these items or shops from internet somehow to send someone a link?
Okay, so your first question, I lost it again. Could you give me a hint again? Sorry, I'm a bit...
will it be like my shop or items in categories?
So basically, at first we looked like, could we have only items, like prevent any identity system, no shops? But we quickly realized that but that's actually not possible. You have a lot of metadata. Like you can clean up the metadata of images, but that's not going to help if they have this general language that runs throughout the whole listing. Like, so unlinkability between items from the same seller is, forget about it. You're not ever going to do that, at least as long as I know. And so an identity system was something that we thought like, okay, this is worth pursuing because, we can't do it right. People can just analyze the language and realize this is the same seller. So we did start looking at grouping things into shops, and that's one of the concepts we're actually working on. And yeah, your second question, basically because it's a hash, we can probably implement something like that. We haven't really given much thought to it, but I could see it working.
Okay, next up.
Hi. What differentiates PARTICL from OpenBazaar?
I've had some looks at OpenBazaar. I think OpenBazaar, for example, uses the DHT. They actually also used Electron and stuff like that. I'm not aware of the exact details, but yeah, they also use a bit of a similar structure, but their protocol, for example, it isn't really super well documented. So yeah, those are things we're trying to solve. I haven't actually looked. I've looked at them and I found them really interesting because at the time I started, there were like 2 projects. I think like OpenBazaar was just getting started and getting funded, and I have looked at them and I even ran them at a point. But it was at a time where you still had to actually run a node to get connected to the network and have a shop. But I haven't looked at their code very much. I think I made one issue on their OpenBazaar repo about their usage of Electron, but that's all I did.
Okay, we have a next question here in the back.
Hello, thanks for your talk. I want to ask, when you created Shadow Cache before PARTICL, it was meant to be a general anonymous currency, and now with PARTICL, in the materials, it is said that it's currency with their own platform. So do you intend to use, for the PARTICL to be used also outside of that platform? And if yes, how do you tackle the scaling issues? Thanks.
Could you repeat that last piece?
How do you solve scaling issues if you want to PARTICL to be used outside of the platform as well?
Yeah. So I'm going to go back. I actually didn't start Shadow Cache or anything. I joined about 1.5 years after they were already running. I found the concept very interesting. Currently we're advertising ourselves, I guess, as a platform. But people make their own mind of what they want to do with it in terms of that. As for scaling, especially on the market listing side of things, scaling we can probably do through IPFS or ZeroNet. We're not actually looking a lot at these things at the moment. We are providing like an upgrade pad though. Like we know we might eventually run into scaling problems, so we're already looking forward to having things like IPFS and ZeroNet, but they don't provide the amount of privacy that we want to have in our system at the moment.
Okay, more questions? I don't see any out over there. Hey,
Hey, full disclosure, I work on OpenBazaar, so I might be a little biased. This is very interesting, but I'm curious, in the marketing materials it says PARTICL has protection to ensure the market does not become the ultimate version of Silk Road. What is meant by that?
Yeah, so basically Shadow Cache kind of stopped and we started working on a different project called PARTICL. And that was because they kind of shaped the idea that we're going to be a Silk Road type of marketplace, which we're not. And so we're looking at things like governance and stuff like how can we use the community to actually remove these items that they don't want to see on a marketplace. And both like also as like a legal protection against us that like they are actually moderating the content, they're curating it. And so initially, we thought we'll have a public marketplace, and we'll be experimenting with some governance models, like how can we give users a way to tag listings and delete them without too much hassle. But we're also looking at private marketplaces completely. Like if you have like, in the same sense that you have like a signal group conversation, you could have the same type of marketplace for us. So basically you could create a private marketplace, share that key and join a marketplace, and then that's none of our business. We keep the open and public marketplace cleaner through creation by other users. And what happens in the private marketplaces, I think, is like the same as with signal group conversations. If someone wants to sell something that is not legal in their jurisdiction over Signal, then that's the same thing, basically. Thank you.
Okay. Next question. Here? No? Okay. I have one question. PARTICL should implement atomic swaps, as I understand it correctly.
Oh, yeah.
So have you done any testing?
Yeah, I think. I mean, I was quite busy with this conference and stuff, but I believe Technovert was actually working on atomic swaps, and I believe one actually happened. I would have to check in.
Yeah, right.
But yeah, I believe like on Monday, or no, I don't know what day are we. Yeah.
Oh, that's okay. That's
some time ago, but I think it happened basically. But
okay, so it's going to be possible to actually like use anything, Bitcoin, Litecoin, whatever, Monero, and the transaction inside will happen in parts.
Yeah, that was one of the things that we were looking in, because as you know, cryptocurrencies are more of an ecosystem, so we wanted to be very inviting to other cryptocurrencies, because cryptocurrencies actually don't have much use other than speculation, and marketplace adoption should definitely be a priority. So we want to have, we want to do things like atomic swaps in the future with other currencies and allow them to exchange them into parts in a decentralized manner.
Okay, thank you. We still have some time, so if anybody has a question, okay.
How many developers are in your team working on the marketplace, and is it a full-time job or?
Yeah, for me, at times I'm full-time. So, as I said, I'm in my last year of my bachelor, so I kind of have to find the balance between the two. But we do have Technovert, who works on the back end. He's full-time. Like that guy just doesn't stop working. It's weekend and he's still going. We also have a few developers. You actually have to look on the website. You'll find it out. Most of the people are full-time. I'm one of the more part-time guys. Yeah.
So nothing more? Nothing? I don't see any hand. Okay, well, thank you again very much. It was a great presentation.
Thank you.